comes to the future, do you think it will be possible to create something like a tool within that map, for example, when you just use, for example, your hydro infrastructure and then your DEMs, and it will predict for you the wet areas?
There's potential for that down the road, but currently, as it exists, the tool does exist, but it's housed at UNB, and it's not intended for distribution. It's not something that we currently intend to license out or do anything like that with it. So currently, the way that these projects tend to work is we own the IP for the analysis, and whoever funds it owns the resulting maps. So that's how the project works currently with Alberta.
Mm-hmm.
So
in that connection, Jae, sorry to interrupt, is there a possibility of overlaying soil maps?
there's always the possibility, because obviously texture is going to have a great impact on some of these results, and we fully understand that, and we fully know that there's going to be cases where there's a stream channel and it disappears, and it's going to start up again a few hundred meters downstream, right? But what we've decided on so far has been, as I mentioned earlier, we're happy enough with the level of detail and precision that we're currently at. Soils information tends to be a lot more crude than the LiDAR-based stuff, so we're kind of concerned that although it is an important driver to soil moisture, it would potentially just lower the resolution of the final output. So that's kind of where we've landed with it so far.
Question about applications of the technology.
Yes.
And you've talked about using it to look at potential flow regimes, is that right?
Yes.
So what are the applications that you'd be using it for from a planning perspective?
From a forest planning perspective, well, in terms of culvert placement and sizing would be one easy low-hanging fruit, I guess. Oftentimes when you're putting a road in, if you have these maps, you can kind of just see if I move the road over a few hundred meters or even tens of meters, I can avoid 3 or 4 culverts, right? And so that can greatly reduce your costs and your potential mitigation down the road that you're going to have to do when you keep having these washouts and things like that, right? So that would be one of the kind of low-hanging fruits, I guess I'd say, of using this information. The others might just be from, say, an oil and gas perspective. When you put a pad somewhere, a well pad, should you move it over a bit, or are you going to have to potentially nuke a wetland that's connected versus a disconnected wetland? Is there going to have less associated impact with removing that wetland? From a biodiversity perspective, we can start to look at, again, these disconnected features. They can be hot spots that where certain biodiversity can be kind of a bit higher than in these connected features and things like that. So I hope that answers your question a little bit in terms of some of the potential uses. And
how about cost per hectare? What are you looking at for this?
Well, the cost per hectare kind of varies depending on the size of the area, and it's not really what I do. That's more up to my boss. So that's something that we'd have to discuss at a later time. But I'll be happy to discuss it later with you.
Has there been any initiatives on wetland type classification with this data set? Or I know you have challenges, but obviously is there an ability to distinguish, fens from bogs and this kind of thing? Or are you just focusing on the depth of the water and that's
never been the intent with this project for wetland classification. It's never been intended to be a wetland modeling tool. It's a wet areas modeling tool, and it's always been associated with hydrological risk. So where the soil is moist, regardless of what type of features exist there, you're probably going to run into problems through the soil moisture, right? So there's other folks that are probably better able to deal with the classification, whether it's through other technologies like hyperspectral or different things like that. So there's potential that there could be integration and cross collaboration with using these data sets to try to identify locations and then further classify those based off of the classifications that we have here. But that's as far as we've ever intended to take it, as far as I understand.
So GOA owns the data.
Yes.
Yeah. So
it's exactly, yeah. And Barry might be able to speak to that a bit more. So.
Are you able to distinguish, at least say, organic, like where the soil water is close to the surface, organic versus mineral soils, or just any kind of distinction along those lines? We have some grad students currently working on that, but there's nothing published yet or that I could share just yet, but it's a direction that we've had some students starting to look.
You can get some fairly decent extractions just based off of the topography of the LiDAR itself. As I'd shown earlier, we kind of have some distinctive, the bare ground, I guess, I don't know how you'd say that, but the texture of the bare ground can be fairly good indicator of kind of organic versus mineral soils, because they tend to be a lot more noisy in a lot of cases. But we haven't really taken it anywhere past where it currently is outside of the current grad student work, which is in its second year. So.
Did you apply any other smoothing techniques to that bare earth DEM?
No.
And that reaching and pre-filling?
No. No, this was all done, the pre-fill was done, and then the breaching as you'd shown. We had to look at doing some stuff on different kernel smoothing methods to try to get rid of the noise, but when we start to do that, we start to lose some of the integrity of the other elevation values that don't have a problem. And there are certain spots that have extraordinarily low relief in Alberta. And when we start to smooth them, they just get even more flat. And so that can be very problematic. So that's why we tried to deal with them just where we have to deal with it. So that's where a sink exists, we could deal with the sink. So that's what we've looked at it, but we've found it is more beneficial because essentially you're just kind of resampling your data, right? So again, we tried to keep it at the highest resolution and precision that we could.
You said you received the loss data, but did you create your own DEMs as well? I know you received like raster versions, but did you create your own as well for the loss?
We did. We had to look at a couple different ways with that. We did our own bare ground classification. We did our own interpolation using different methods to try to tease out a bit more information. But where we finally landed was from a consistency stake in terms of having this data set congruent with all the other officially distributed data layers within the GOA. We use the GOA's DEMs.
Was it just a linear kind of interpolation?
Well, we looked at a few different things. We tried, as I'd shown, or was talking to someone else here earlier, we tried like a tin to raster conversion. We tried a few different interpolations based off of natural neighbor, or there's some modified shepherd methods, and just a bunch of different ones that we tried. Relative to some of the field analysis that we had, we just did a bunch of different runs through on different interpolation methods to see how much they changed the resulting wet areas classes. And there wasn't a whole lot of change, so we just decided to stay with what we had. So.
For your purposes, are there better times of the year to do the flights to get data acquisition?
For our perspective, the bare ground is what's the bread and butter of this project. So leaf off tends to be the best. In softwood areas, it's kind of doesn't really matter much, but leaf off with no snow is going to be the best results. And again, the open water features can be a little bit problematic. So ideally, we're going to have, leaf off without a whole lot of soil moisture. So more the fall than the spring. So the fall tends to be the ideal time to get these better bare ground representations.
Do you use any overlapping when you fly when you do your LiDAR operations, or?
We don't do any of the acquisitions ourselves. We're a research group within the University of New Brunswick. All the LiDAR acquisitions are done in the province generally by two providers, so Airborne Imaging and Northwest Geomatics. And the overlap, they do have overlap. Those specs aren't necessarily set by the GOA. They're set by the provider in order to meet the specifications required by the end user. So like the GOA will decide on a minimum point density, and the provider will decide on an overlap that they require to meet that, as far as I understand. But there tends to be, as far as I know, about a 50% overlap on each of these projects. So, yeah.
So you said you had 1 point per square meter density?
Average, yes.
Yeah, an average. Is that enough to make the good DM 1 meter resolution?
We find it does, yeah. We have other data sets in New Brunswick. We've done some other trials where we have up to 15 points per square meter, and then we can obviously downsample it and thin it out to kind of look at the impact of, or the value of having 15 to 6 to however many points we choose. And 1 point does a fairly decent job at getting a good bare ground representation. Obviously underneath the forest canopy, the true density is going to be a lot lower than the average, but still in a lot of cases it does a very, very good job. So 1 meter is it's not the top of what can be achieved now, but in terms of a good quality data set, we're very happy with what the GOA has provided to us. So.
Have you done any volume estimation with your model, and have you checked any accuracy of that?
Volume in terms of forest biomass volume?
Biomass, yes.
That's been outside.
volumes.
That's been outside the scope of this project. There's been some other work that's gone on in terms of forest biomass estimation and different things like that associated with LiDAR data. But there are problems associated with LiDAR, even in terms of getting an accurate canopy height estimation. There's always going to be an underestimate because you generally don't get the true top of a tree with your point. So there's kind of qualifications and calibrations that have to be done to try to make that happen. And again, when we're looking at data sets that can be flown from 2008, 2010, 2012, right, we have some of those issues. So you kind of have to bring everything to the same time scale and then start from there. So we have some other projects that are looking at that, but not here in Alberta. Yeah, sure.
What's the timeline for finishing the project within Alberta?
Barry could probably speak to that better than I can, but I know currently the plan is by 2017 to have the entirety of that 25 million hectares run with the latest version, or with the final version. So the areas that we've rerun down the south, that was phase 1, all that red piece, that will all be rerun. The whole area will be rerun with the final methods. Now, as we kind of move into different areas, we're probably going to run into different challenges. And that's what's been happening so far, right? So that's what keeps this as very interesting research for me, is as we move into different areas, you know, Alberta is 6 times bigger than New Brunswick, right? So, which is where I'm from. So as we move somewhere different, we have a very different landscape. And that can cause, you know, different issues, as we saw with the bog extraction, things like that. So it's very likely that there'll be version 3 and 4 before we get to the end of this project, and then that final version will be used to rerun everything. So 2017 is the intent, with the latest and greatest that we have.
And outside of Alberta, is there any interest from other provinces within Canada?
Absolutely. We've done work in many other areas. The New Brunswick, we've mapped entirely. Nova Scotia, we've mapped entirely. PEI, we've mapped entirely. So a lot in the Maritimes. But the difference is Alberta is in a very privileged position in terms of having so much LiDAR data. A lot of other provinces don't. In New Brunswick, we have about 10% of the province flown. Same, PEI has very little. Nova Scotia has just small pieces here and there, because oftentimes those projects are flown for other uses, and then we get the data afterwards to process through wet areas mapping. So in our province, there's a lot of issues with flooding and things like that. So that's when they'll fly LiDAR, and afterwards we get the data and process it through with these mapping methods. But Alberta is, as far as I understand, the only province in Canada that has, you know, such a large proportion of LiDAR data. And LiDAR is what makes a huge difference in terms of the quality of these maps. So.
You showed moisture today split into wet, dry, moist, and wet.
Mm-hmm.
Is it possible, do you think it's realistic to get any finer than that?
I suppose you could, and there's been a lot of interest with our field staff for this coming year to try to start to look at the gradations across these zones, not just, you know, the extent of a wet feature, but, you know, how fine can we pick up these gradations between these zones, and, you know, are they going to be truly accurate and things like that. And sometimes we have a lot more broad of a gradation, sometimes it's a very sharp and abrupt transition. So that's the intent for this summer, is to try to get a better handle on, you know, how fine scale can we take this. So
just to add to that, the provincial perspective is that we fund UNB to develop the model maps. You look now at ULA and answer that specific question.
We got a number of projects where we're looking at these various specs. So
yeah, there's 5 projects right now here funded, and it's to ask that question of, does this type of information give us better insight to moisture availability than anything else?
yes.
Are the results going to be static, or are they going to be influenced by current moisture conditions?
It's definitely going to be influenced by, you know, current conditions, right? We fully understand that you could go there in March and see a very different landscape than you're going to see in August in terms of soil moisture. But these maps at the 4 hectare flow initiation threshold are what we tend to say is the areas that tend to be moist most of the year. So that's just kind of, if you go in the spring, you're going to see a lot more moisture on the landscape. But this tends to be kind of the midsummer kind of average, I guess you'd say. So, sure. Well, thank you very much, everybody.
Well, thank you.